Katie, and she's one of the things like she actually developed one of the first apps for the blind people to be able to deposit checks in their phone. Yeah, she's pretty smart, and I wanted her to be, she kind of wants to be, but she just lets. She's less likely to have to work behind them. But she's just brilliant the way her mind works. But right now she's got she lives in Texas. It was our place. She lived in Texas. We all met at a Texas Women's Concert, a really big one. And she and a friend from Canada met there. And they started like, so now she's coming to see us. That's cool. Right.
Once it was like late at night, so they didn't do anything.
We have a lot of people at home trying to figure out who is actually with us at home. They're doing really good about putting remote in their names. Still hard. So I'm missing a few. This bunch. I gotta tell you, you guys, I don't like seeing clusters, huh? All right. And then I heard from Chantel. Stuck at the doctor, something fun. We have all sorts of people stuck all sorts of places, and some are actually working from home. So let's see if I've got them. Jesse Whitaker. Okay, I think we're pretty close.
Zach is online. How about that matters? Or is it the Zoom?
Yeah, I've got him.
Oh, okay. Oh, yeah.
It's hard to tell on that screen. I don't like it. I wish it wouldn't leave that other screen. Maybe I'll send that as an enhancement, because apparently the company that is doing this attendance for us is pretty new, and this is like their main product. And so they're changing things as we make suggestions. So I should take advantage of that and say, could you just stay there where I see the seating chart? Instead of jumping back to this other screen that's not very helpful. How are you guys? Gosh, it's been a week since I've seen you. It happens every week. I don't know about this hybrid thing. I'm trying to get used to it. You guys are doing great with it. I mean, as far as I can tell, I mean, work's coming in looking really good. I think that you guys are doing awesome. So let me know if I'm not seeing something that I should be, because I know you're working hard, really, really hard. Last time, What did we do? Oh yeah, we got started with things and everybody took off with collaboratory. Let's look at that real quick. I have my Chapter 3 collab notebook that we worked on last week open, and I'm just looking at that salesperson commission program. And the reason I have it open and I'm looking at it is because we started our Python quick reference last time and we didn't get very far. So I kind of want this open so that we can use it to work on our quick reference. Let me bring that up. I'll let you guys find yours. And if you remember, what I was thinking is, I see students struggle to put syntax together to do the things that they want to do, because there's so many resources available online for Python. It can be kind of hard to filter through all of it to just get just what you need. So we'll just create our own quick reference and just put the things in it that we're interested in, and then we don't have to worry about navigating through all of that other information. So this is all we had so far last time. We put in the function print. And so our first line shows an example of printing out the string hello world, how that would work. The next line underneath it is just an empty print statement, so that would print out a blank line. And to some people, they look at that and are like, well, yeah. And other people, other of us, are like, oh, that's how that would work. So it's just kind of one of those things that you might have already realized that, and we going, well, duh. Now we could also print like a variable, right? So I could say print important string and then a variable. And that would print out important string and the contents of variable. Sure. Is that better?
Yeah.
Now my print here, I'm glad you had me do that because I didn't realize Word was helping me there. And I'm going to keep trying to make those initial letters lowercase like Python wants them. Now I've found that if we go ahead and highlight some things, it can help us. So if I had this printed out and I was using a highlighter marker, one thing that I would want to highlight are names of functions. So I'm going to put that down under our table. I'm going to come down here a little bit, and I'm just going to put functions, and then I'm going to highlight that. So I think for functions, let me check and see what color I used in the other class so I can be somewhat consistent. For functions, I'm going to use the green highlighter color. So when we do a print statement, it is the word print that's the function. That's the name of the function that we're calling. So I'm going to highlight that word in our examples because it's a function. Now we could get crazy with our highlighting of things, but then that might make it kind of hard to read. But think about it. What things are areas of confusion for you? I noticed in the other class yesterday that a bunch of people were having trouble with printing out some words and a variable. A bunch of them kept putting the variable like outside of the parentheses. And so then they were getting all sorts of errors from Python. So in that case, you know, maybe it would be important to highlight the beginning and ending parentheses to show that everything that's going to be printed needs to be inside the parentheses. I do have a former student who's having some sort of like meltdown. So I apologize, but I'll check Discord and those things that pop up today because we're trying to get him some assistance. He hasn't been around for a couple of years, but you know how people, when they're in a bad situation, can reach out to places that they've been before. So we'll get him fixed up. Now, what I could do is I could highlight the strings, you know, all the stuff that's within double quotes. I could highlight the variable. We'll do that here in a minute. Let's add some more to our quick reference before we go any further. One that I like is, see, I'm going to put a couple of blank lines in, and I'm going to do global. Maybe if I can type global. Now I've got to change my highlighting here because that's not what I want. So here are a couple of things that I can do. When we choose to use the keyword global, we are declaring a global variable. We declare those before any subprograms, and then we have to declare them again in subprograms that update the variable. So what I'm referring to here is we have to declare sales amount as a global variable at the top, but then we have to declare it again in our input module because we're going to update its contents. So anytime we're going to update its contents, we need it declared. So let's do some highlighting here. For the keyword global, that is a keyword. So I'm going to say that keywords are going to be highlighted in, let's do fuchsia. Because I actually noticed when we use Colaboratory, it actually makes our keywords fuchsia. So maybe we'll change some of our highlighting here to match Colab if we see that there are other matches. All right, so what's a keyword? Global. That is a term that Python understands, and it has to be typed exactly that way, and it has to be used in this way. So then I'm going to say that a programmer defined name, this could be a variable, but it might be something else. So I don't want just variables. I want to declare things that are programmer defined names are going to be blue. So my variable name would be programmer defined. I can make that variable name whatever I want. This variable, that would be programmer defined. I can make it whatever I want. So we want it to be where when we look at our quick reference, we can say, oh, that's fuchsia. I can't change it. It has to be that exact wording. But oh, that's blue. That means that's something I decide. That's an input that I give. Let's put some more examples in so it makes a little bit more sense. How about our input statement? We used it in its simplest form. Turn off my highlighting here. In its simplest form, we said, it won't stop for me. Input. Here is the input prompt. So when we run our input function, input is our function name. So I will make it green. And then everything that we're using for our prompt In this example, it's just a string, so that would be something that we would decide. So let's put a description there. For this statement, we're just prompting the user for input. And I'm not sharing, I'm so sorry. Okay, how's that? Let's give our remote people just a second, since I haven't been sharing my screen, so that they can type some stuff in. Mean of me. You guys need to yell at your people in class and say, hey, why didn't you tell her? So I'm trying to do 75 things at once. It's hard, I'm old. Let them get caught up. This morning I just gave up and had a student drive because the stuff that we were doing, I just couldn't make it work. That's what I might do to you guys today. Just one of those kind of days. Okay, so we've got our input statement here. We know that it prompts the user for input, but we did a lot more with that thing than just use it in its vanilla mode like that. So let's put a couple more examples. What if we wanted to save the input our user gives us in a variable? If we want to do that, look at it. Sorry, I'm having word trauma. Like I said, one of those kind of days. I could set my variable name equal to the result of the input function. Somebody's not muted. Okay, so this statement, we're using the input statement, prompting our user for input, and whatever they type, we're going to save that in this variable. So we need to highlight some things. What's the function we're calling in that sample? Yep, that was right. Input. Which of those things is a programmer defined name? Variable. The string is also, but we want to kind of not worry quite so much about that at this point, because it'll just get a little bit too nitpicky. So our description, we could just say user data will be stored in variable. Then we saw that if we use the int function, we could cast our data as an integer. I guess I'll say variable. Now, some things I need to fix. Variable is my programmer defined name. Int is my function. And I should not have any highlighting on my parentheses. Now, sometimes I think we do these quick references and some students never look at them, never use them. That's okay, because what we want to do here is the practice and the kind of exploring this syntax that we have. And just any time that we can talk about it and think about it more, that's going to help us a little bit with using it. So the other thing that we haven't got here that we did in our code was the def statement. we said that the def statement allowed us to define our own functions. It won't get rid of the color for me. It's like, no, this will stay green. There we go. So in our code, we did def and then function name, and then we had open and close parentheses and a colon. So we have a lot of things going on there in this statement. So first of all, let's put our description over here to the side and say def keyword means define a function. So it's a keyword. So I'm going to highlight def and use that terrible fuchsia color. So if you notice, as we're looking at our code, we use a lot more functions, and we will see that as we go, that our functions are something that we'll use a lot more of, but these keywords are really important when we need them. Now, when we define our function, the function name is something that the programmer decides. So it's a programmer defined name. We can make that function name whatever we want it to be. I'm going to add a little bit more here. So besides the def statement defining a function, it also begins a body. The body that it begins is the function body. And a body just means a chunk of code. Could be one statement of code, could be many lines of code, but all of these lines of code are going to be in this function, part of that function as its body, kind of like a paragraph. And then one last thing, that function body, oops, I'm in the wrong place, is indented. And the colon indicates that. So the Python interpreter, as we're typing code, it sees that colon and it says, oh, it's the beginning of a body. I'm going to go ahead and indent when they press return to go to the next line, because that code should be indented. And everything under the def statement that's indented is part of that function. So what do I do when I'm done with the function? I outdent. I just quit indenting, and that makes the function end. Now, a couple of other things here. Let's put a few more lines. How do I call a function? I just type its name followed by the open and close parenthesis. So that is going to be a green function, but it's blue because we made its name. So we could go either way on that one. So when I type just the name of the function in my code, that calls the function. So I'll go to it, run all of the code that's in its body, and then return back to the statement following my call. All right, we'll add a little bit more today because we're going to start looking at if statements. So anything you can think of to clarify? We'll see as we go. I'm going to save that though, because I want to start looking at our new stuff. And whenever we start a new section or a new topic, you guys know us teachers always do the showing you a presentation. We show you what you're going to learn. We try to learn it, and then we try to review. Sometimes, in our class especially, you guys are reviewing at home, which I appreciate. But today, let's mix it up a little bit. Sometimes it's hard to listen to that presentation, me talking about stuff, when you haven't even seen what I'm talking about yet. So let's go ahead and create a program, and then we'll back up and talk about our if statement. So I'm going to find that Python programming book for the absolute beginner, because that's where I want to start. And if you don't have it, don't worry. because I'm going to bring it up on the screen. So we can just look at it together. So we are in chapter 3 of this book, but we're in chapter 4 of our Prelude to Programming book. So let's create a new co-laboratory called chapter 4. So I'm going to go back to my Google Drive and close this one, old collab document, and then I'm going to create a new one. So I'm going to do a new, more Google Collaboratory, and I'm going to name this one Chapter 4. And I noticed that it keeps that .ipynb file type in your description, which you don't need. It's up to you, but I'm going to select that because I don't really care to see that. And I'm going to say this is Chapter 4, and I'm going to put H101 because I already have one for that other class. Now I'm going to toggle back and forth a little bit. So let me know if I'm making you dizzy. I'm going to go to chapter 3 and take a look at our Python programming textbook. We're going to talk about if statements this chapter. And in our textbook, our Python book, they threw a little bit of looping in here too. So we'll see how to create kind of a while loop that keeps things running. But our main focus for this chapter is going to be if statements. So I need an if statement to add decision making to my program. Why would I need to make decisions? Well, you guys know we make decisions all the time, every single day, right? So the first week of class, I told you about algorithms. And I said that an algorithm is just a step-by-step list of instructions to do something. Well, what if we need to make a decision in that algorithm? The algorithm I gave you was how to get to my neighborhood. What if you leave OTC, and then this has happened to me before, and you're sitting on Sherman, and you look down and you see that there's a train stopped between you and Trafficway. If there's a train there and if it stopped, should you use an alternate route? That's a kind of a logical decision you might have to make when you're driving. And so, yes, I would say, oh, I should go ahead and turn because that train could sit there forever. I just don't know. So when we make logical decisions like that in programming, we're going to use an if statement to check the situation and see what's going on. And an if statement returns true or false. So it's just like a Boolean variable. It's just another way for us to get the true or false. So in this chapter, the big project they're going to be working on is a guess my number game. And it's a fun application and it's always fun to create. So in a guess my number game, we're going to start with some sort of number and we're going to ask the user to guess it. And we're going to, in this case, give them some clues. Like we'll say, oh, you should go lower or higher, depending on what their guess is in relation to our number. And then finally, we'll tell them they guessed it if they get it right. In this example, we're going to even keep track of how many tries they've used. And we could limit that if we wanted to and say, oh, if you're out of tries, you lose, or whatever we wanted to do. Before we can code this game, though, one thing that we have to work with is a random number. We have to somehow get this number to start with, the number that we want the user to guess. So a random number generator is a really good way for us to do that, to get a random number. In our textbook, they talk a little bit about random numbers. Python, like a lot of other programming languages, uses a formula, a mathematical formula to generate a random number. These random numbers are really called pseudo-random because they're like they're random, but they're not exactly truly random because they depend on this formula. The formula is only as good as the seed value that it's given. And a seed value, when we're working with a random number formula, is like a starting point. So if I have a seed value and you have a seed value, and we use the same formula, we're going to come up with the same random number, aren't we? So that seed value needs to be really, really dynamic, something that changes a lot. So usually, if we have to supply the seed number, we use like the current time. And we'll go way out to the millisecond, because that's a very unusual number. Then if him and I both use the current time, chances are we're not going to get the same exact millisecond number, even though we're running side by side. So we'll get different random numbers. So that's important. So they say that if you really are going to do like a casino app, then you have to go to find some scientific and natural and unpredictable random numbers, which I thought was really interesting. I knew that we had pseudo random numbers, but I didn't realize that they wouldn't qualify for casino apps and stuff, you know. That's my retirement plan. So anyhow, we've got this figured out and we want to make some random numbers. So they're going to show us how. They call this a craps roller. I've never played that one, but it's where you roll the dice. And so we just want to simulate rolling two dice. So that's all our program's going to do. So let's put this in. Before we get started, let's get our notebook organized. I'd like to add a section header. We hadn't done that before. But if you click on this table of contents icon, you'll have the option to add a section. Let's add a section here. And here's our section. I'm going to give it a name. And this is going to be, we'll call it random number craps roller. Now, when you click someplace else, like in some code, it finally will close out that section header. When you're working with Collaboratory, notice where your cursor is. You have like a context-sensitive menu there. So if I wanted to do anything with this line, I could use this menu. I want to move my section header up above my code. So I'm going to click on my section header and use the up arrow to move that cell up above that code cell. Now I'm going to close my table of contents and find my code. So I should be ready to go. We'll keep our notebook kind of organized. We're going to have to decide as we go, you know, how much stuff we want in an individual notebook. And some of that's going to depend on how much needs to be turned in and things like that. So I'd love to hear you guys' thoughts as we're working, because it's only with student input that we come up with really good ways of handling things. All right, let's write this program, this script file. I'm going to start out with the 3 double quotes for our comment block, because last week I was doing the hashtag, the pound sign. We like to mix it up and try some different things. Our script here is going to be craps roller. Make yourself the developer. And our date is going to be 9/29. We're going to generate random numbers for dice rolls. And then I'm going to use the 3 double quotes to end that block comment. How's everybody doing at home? Do you guys need anything? Are you okay? Some are responding, yay, yay. Okay. Got comments now. In order to generate a random number, Python actually includes some code already for us, because that random number generation calculation does not sound fun. So we don't want to recreate or reinvent that wheel. We'll just import the random library for Python. Whenever we want to use some Python code that we don't have in the default Python interpreter, we can usually find a code library that's already been created for us. In this case, the code library is named random, and we just use the import statement to tell the interpreter to copy that code library into our code.
Is that the same code? Like if I was Discord bot as well, I do import random, is it the same library?
Yes, it's the same library if you're using Python.
Okay.
So it should be the same. Now, realize your random library is in your file system. And remember how I keep saying all these different versions of Python and all these things. So you could end up with some differences. But yes, it's basically the same library. So we're importing in that random code library so that we can use the functions that it contains, because it contains functions having to do with random numbers. So let's use one of them. For our first die, we're going to set it to a value, and we want to use the random library to set the value. Whenever I'm using one of these external functions that's coming from an import library, I have to name the library first. So here, random matches. After I name the library, I put a period to tell Python that I want to find a function within that library. And the function that we want to use first is called rand init. So rand int, sorry, I initted and I should have inted. It just generates a random integer. Now the way this actually works behind the scenes is when Python goes through that big formula based on that seed value, the number that it comes back with is going to be a number between 0 and 1. It's going to be a decimal, right? It floats. Internally then, Python is going to do multiplication on that decimal number to make it into an integer, a whole number that you've requested. Right now, we haven't requested a certain number. We've just said, give us a random integer. We can specify a range. And since we're working with a die here, a die can only go up to 6. So we want a range from 1 to 6 for a random number. So we're going to put that within our parentheses, and that way we're setting those values up as arguments to be passed into that random int function so that it gives us a number between 1 and 6. Now we want to go ahead and allocate a second die. And for this die, we're going to use the random library again, but they want us to experiment with another random function, rand range. And this is just a function that is already in that library. How do I know what it does? Well, I could go Google it. Python rand range. And then I'm going to see all sorts of information about what that function does. Now, if I look, I've got the Python docs. These can be kind of hard to follow. W3 schools are usually pretty good. That's usually a really good place to look for information. So I'll click on that W3 schools link. And sure enough, it says that rand range returns a randomly selected element from the specified range. What is the specified range? Well, it says you can pass it a start number, a stop number, and a step number. So the step is normally 1. I could make it 25 if I wanted to. So I could start 0, stop at 100, and make my range 25, and then I would just get 25, 50, 70. But that's not what we want. Notice that our default start is 0. So when we're doing the random range, we could end up with 0. In our example, they just want us to put in a 6. And because the random range can return a 0, they want us to add 1 to it. So the random range function, the way we have it set, would return values between 0 and 5. So we have to add 1. So notice how they work just a little bit differently. Now we want to go ahead and set up a variable called total that is going to be the combination of both of our die. So die 1 plus die 2. And then let's print something out. We're going to print out you rolled a, and then after that string, we're going to print out the value of die 1. And then after the value of die 1, we want another string that says and a. And then after that string, we want the value of die 2. Then another string for a total of. And finally, the last thing that we want to print out is the variable contents of our total. So that's a pretty messy print statement. We could change that around a little bit if we wanted to split it up into multiple statements, but that's pretty common for us to see things like that. Now notice the way Colab is highlighting this. It'll really help you make sure you've got it right. All of our strings are being highlighted in red. Our variables are black. So anytime we're looking at a variable name, we should see that it's that black color. If I accidentally had my variable name within the double quotes, it would just be red like the rest of that string. Let's run it. Is it going to work? Check. Check. Mine's thinking. Takes it a minute to allocate it to virtual machine. And then I get my response here. You rolled a 4 and a 2 for a total of 6. Let's run it again. We should get a different number, right? Each time? Question?
Yeah, it's just, so I noticed we didn't really put any spaces between the A and it's automatically filling in a space.
Good question. So whenever we're looking at our textbook, they tell us to use a plus sign here to concatenate instead of this comma, right? In Python, we're going to use that plus sign, but it actually kind of throws a kink into things. Python gives us the option of using this comma instead. And when we use the comma, it automatically puts a space between items where the comma is. So that's a really important question because it's just a little bit different of the way that Python works.
So, and whenever I was having trouble, I had the plus signs there. But there was some spots where I had to use the comma. It wouldn't let me use the plus sign.
Right.
So it forced me to put that space there. How would we remove that space?
We'll look at it soon, but what we could do is each of these things that are a number will have to be cast as a string to make this work so that it's all one big string. So if we use the plus signs, everything has to be a string. With the commas right now, it's letting us use string, number, string, number. So we'll get to that point. Now, are you getting different numbers each time you run it? And you're getting different numbers than me, right? I hope. Let's try something and we'll see, maybe we can all get the same number so we can see how random number generation works. Copy your code. Just copy this whole thing for me. And then let's go open a new website. The site that I want to find, I can find really easy if I search for Visualize Python. And I could just save this as like a shortcut, but that wouldn't be any fun. So the one I'm looking for is this Python tutor site. So it usually comes up at the top. And I use the same site for Java. But I'm going to go there. And this site lets me execute code online, but it's going to show us the contents of memory, or try to as we run. Now, when you use this Python tutor site, make sure this drop down up here at the top is set to Python 3.6. Because like I said, you can use this thing to run a lot of different languages. Now I'm going to paste or Control V my code from Collaboratory. Got it? Let you do it. Now click Visualize Execution. When you go to the Visualize Execution mode, you should see, let me move mine down a little bit. This little red arrow is showing you where the visualizer is right now. So the visualizer has skipped that whole comment block and is sitting here waiting. It's ready to run the next line of code when I click next. Can I click here? No, of course not. I've got to reset everything and see if I can get that to work. Let's click next. The first thing it gets to now is it says, I am ready to run this line of code that says import random. Let's click next. Notice we have nothing over here. When I click next, it's like magic. Ah, now we see we've got the random library loaded. It's just showing us that that module is out there. So I'll click next. Now on this line of code, I'm going to allocate die1. Sure enough, there's my die1 variable, and it's given it a value of 4. Now it's ready to allocate die2. I'll click next. There's my die2, and it also got a value of 4. Now if I click next again, I should see my total variable. There it is. And finally, all my printout. Did you guys all get 4s too?
Yeah.
Yeah, cool, isn't it?
What? Well, how'd you get a 3?
Random.
No, because actually, because she probably got into it just enough at a different time than us, that she got a little bit different of a seed value. But what happens is this site is running on a server, and they have things set up so that every person who runs on their server is using this same shared random instance that's already running in memory. That way, they can keep their server running efficiently instead of it loading 20 versions of the random number generation library for each of us. Their server is like, no, I already have the random number generation library loaded, and it's just sharing that with all of us. So we're all getting basically the same random numbers. So it's kind of neat because I like this site a lot because it lets you have a visual of what's going on in your code. But I think that's cool that as a neat side effect, we got to see that random number generation can go awry pretty easily if our seed value is no good. So we're going to come back to this site, but let's minimize it for now. So that's our first program for this chapter. So we didn't really do any if statement stuff. We were just getting ready. So now let's write another one. So I want to add another section. This section is going to be the password program. So it will be an if statement. And I want to add some code after that section header, our actual program. So this program, put some comments. We'll call this our password program. And our purpose here really is to use an if statement. I'm going to end my block comment. So we're going to pretend we're a password checker here, and we're going to ask a user for a password. So we need a variable to hold that password. Oh, they'd like us to give out a nice welcome message first. Let's put in our welcome message. We're going to print out, this is kind of an important welcome message to the whole scheme of things. Welcome to System Security Inc. Our next welcome message line is going to say dash dash space where security is our middle name. See how cute that is? We had to put that first line in correctly, or the security is our middle name as a byline wouldn't mean much, would it? So that's going to be our nice welcome message that prints out at the beginning of our run. Now, we need a variable to hold what the user types in, and we want them to type a password, so let's use password as our variable name. Our input statement is just going to say, enter your password, colon, space. Now, if you notice as I'm typing, Collaboratory is learning, isn't it? It's like popping up with suggestions for me and things like that that it wasn't doing earlier. So as its AI kind of learns what we're doing, it'll be really, really beneficial, and it'll have all sorts of suggestions for us. So now I'm going to ask for my password input. When the user types their password and presses enter, the password will be saved in this password variable. So we can look at it now. Let's do an if statement. We'd like to check to see if the password is the secret word that we want it to be. So we're going to use the keyword if. We're going to say if the password variable equals the string secret. They got it right. Now, when we're doing an if statement, all of the lines of code that execute if the if statement is true are called the if statement body. And they're going to be indented under the if statement so that Python can tell what lines of code go with the if statement. So we need a colon to tell Python this is a statement that starts a body. A couple other things about our if statement. Notice that we have two equal signs instead of just one. When we're assigning a value to a variable, we use one equal sign. When we're testing for equality in an if statement, we use two. Otherwise, Python wouldn't be able to tell the difference. So our if statement is pretty simple there. We're saying if this condition is true, I want you to do some things. And what we want to do is print out a message. Our message is going to say access granted. Let's go ahead and do another line of code. A lot of times our textbooks just show us one line, and that confuses people because they're like, I didn't know I could do another one. Sure, I could do a whole bunch of lines of code here. As long as they're all indented, they'll only execute if my if statement is true. I'll go ahead and print another message like, congratulations. Now we should be ready to run our program. Now I know we don't have any modules or functions or anything in here, but that's okay because we want to really focus on our if statements right now. So I'm going to run this. So I see my welcome message. Enter my password. I'm going to type, they want it to be secret. So I'm going to try to type it correctly. And if I match, I should see my print statements get executed. Congratulations, yay. Now, what if I type it wrong? I'll type something that is the wrong password. Nothing, right? So if my if statement is true, the if statement body executes. Only if my if statement is true. So here I'm saying if this is secret, these are the things that we do. Okay? Make sense? Let's talk about if statements then. We're going to keep this and hang on to it for a minute, and we'll come back to it. But in Canvas, let's go look at our module for the week here. And I didn't mention anything about the Unit 1 exam. Sometimes I have to go over some things that people did wrong and stuff, but I don't think you guys did anything wrong to tell you about. So we'll just continue on and be like, good job. All right, so there's 2 PowerPoints in this week 6 stuff. One, the top one is the textbook one. The other one is kind of an updated one. So let's grab the extra. And I'm going to go ahead and download it. I don't think it has any animations in it for you guys to worry about downloading. All right. So whenever we're looking at if statements, I've been a programmer for a really long time when I started teaching, and I couldn't figure out what they were talking about with selection statements. I just wanted to teach people about if statements. Well, they call if statements selection statements because we use the if statement to select which lines of code execute. So we're only going to execute the lines of code under our if statement. So it's kind of an interesting way of naming it. It's also decision making, but anything like that is what we have going on here when we're working with decision making. The important thing is our condition. The condition in the program that we just wrote was password equal secret. So that whole part was the condition. The condition is the part that can result in a true or false result. So here we have a flowchart symbol for a decision-making section. Anytime we're making a decision in a flowchart, we're going to put the decision diamonds. And in that diamond would go our condition, like password equal secret. That's the condition we're checking for. Then from our decision diamond, we have a true path and a false path, or a yes path and a no path. But we have to have 2 paths coming off of our decision diamond for our flowchart to be accurate. So let's look at our operators here. We already saw that 2 equal signs is what we use to check to see if something is equal to something else. Remember, we're just trying to get true, false. That's what we're wanting. Is this true? Is this true? We just want to get that condition down to where the system can tell us if it's a true comparison or a false comparison. So equal to is 2 equal signs. Not equal to is exclamation equal or bang. Programmers will call an exclamation point a bang. Bang equal. Now here is the operator for less than or equal to, greater than or equal to. Those are our relational operators. Some people will call them the comparison operators. The textbook would say, those people are wrong. These are the relational operators. So remember, they can be pretty picky about those terms. They're comparison operators when we're doing math, but relational operators when we're doing programming. So some things about our condition. Our condition has to have 2 sides or 2 operands, like A equal to B. Both sides in addition to the relational operator. Those sides, those operands could be variables, like in this case. They could be literal values, like this is a literal value in a string. Or it could be like some sort of number. I could have those right there in my code. So when I'm forming my condition, my test condition, I have a lot of flexibility. So here's one. Let's consider our classroom, and each of us is executing this code, and we've got a row number. And we've set our row number, well, the row number we're looking for here is 2. So let's look around the room, and if we executed this statement, if row number equal 2, then we ask our row number 2 people to stand. They would stand up, but let's not ask them to stand up, let's ask them to raise their hand. Will our row number 2 people raise your hands, please? Row 2, yay. Okay, now I have a question. Did the rest of you do anything? No, you checked. You're like, I'm not in row number 2, so I just can ignore this. But the people that it actually applied to, they did something. They executed that if statement body. It can be a weird concept to people. All right, so good job. Here's our flow chart for our if statement. And here's pseudocode. So a little bit more about that. Whenever we're looking at forming our condition, when we're testing for equality, like in this case, if I say if row number equals 2, is that exactly the same net result as saying if 2 equals row number? Same thing's going to happen, right? Either way. Now, developers prefer syntax to be written like this, variable equals value, but either way would work, and we would get the same true or false result from that. So placement would not be important when we're checking for equality. But let's say we're looking at a less than condition. A couple of things here as we're looking at it. The condition part is in green. The if statement, the then that comes after it, that's extra syntax. The condition is just this part that's in green. In this particular example, the less than is the relational operator that's within the test condition. In this example, we want to again look at our row numbers, and in this case, we're saying if row number is less than 2, we want people to raise their hand. Raise your hand, less than 2 row number people. These are raising up hand. Raise your hand or I'll make you stand up.
No.
Okay, so look and you see it did not affect the rest of you. It's important for you to realize that. Now, what about our order? Whenever we're doing a less than, is this the same as that? No. So our order of operands does matter when we're not testing for equality, right? We can't, programmers will sometimes go in and say, I'm changing all this, I hate the way he did it, I'm gonna put all of my variables first and all of the numbers second. And we have to be really careful if we're gonna make a change like that, because we could be changing the way it works. What about a greater than condition? This one we should have more people raise their hand, and all of you poor hand raisers can look back and laugh at them. Here we've got if row number is greater than 2. So all of you with row number greater than 2, raise your hand. Oh yeah, look, they were able to do it. Woohoo! Now, when you look at this, thank you guys. Row number is the left operand, right? It's on the left of the comparison operator. 2 is the right operand. And you guys are looking at me like, yes, but you will read instructions to programmers that will say, update the right operands to be this value. And that can throw people for several hours if they don't really think about left operand, right operand. That's all we're working with. Now, I did this in pseudocode, and I won't make you guys, but if you were to ever have to write an if statement in pseudocode, you would want to have these keywords, the keyword if, and then the keyword then. And this is like a holdover from old Visual Basic. So we're going to say if condition, then do this stuff. And then at the end, we're going to have the end if keyword. Remember in Python, we don't have to have anything to end an if statement. We just quit indenting. Now, all of the lines of code that are within the then and end if are the if statement body. And again, if we're looking at a flow chart, we just would use the diamond and we would have true or false. You guys would not believe how many people will try to do a flow chart and they'll stick a rectangle in there and then they'll be like, I can't make 2 lines come out of it. It doesn't make any sense. That's because that's why the diamond is used there, because it makes the perfect amount of cents for us. Cents. People crazy. Okay, so the if statement we did in our code is called a single alternative. The single alternative means I have an if statement and that's it. There's only one way I'm going to do the if statement body code, and that's if the if statement is true. So when we said if password equals secret, that was a single alternative. That's the only choice we had. So what if we wanted to do something if they got it wrong, if they get the password wrong? We'll add this in. We would use an else clause. So when we're working with an if statement, we have our if part, and then the else keyword says, do all of this stuff if that if statement wasn't true. So if the if statement is true, do the if body. If the if statement is false, do the else body. That makes sense. And then put at the end if at the end. Sometimes, oh, here we got to do our else. Here we have a Boolean variable called brown hair. And in our brown hair variable, each of us is an instance of the execution of this program would set our brown hair Boolean variable to either true or false. Then we could do an if statement that says, if you have brown hair, then do something. In our flowchart, we can do that same kind of thing, checking to see if they have a certain characteristic. In our else statement for this one, we didn't do very much. So let's go on from it and look at another example. What if we have multiple alternatives? Here in this case, I could say, if the password is secret, then they get access. Else, if the password is super high level secret, they get even more access. Else, if the password is low level worker, they get less and less access. And finally, we can say else, you're denied access, you didn't get any of the passwords right. So in a multiple alternative, we have the option of saying, was it this? Oh, was it this? Oh, was it this? And we can have different code bodies associated with each of those so that we could assign them the right level of access. When we're doing this in Python, we'll use the elif. So it's a little abbreviated. So here's our multiple alternative, and I want everybody to try this one. I won't make you stand up, but we'll do some sitting things. So in this example, instead of using a Boolean, we're using more of a flag, an indicator, to say what color hair a person has. So our hair color variable is an integer. If we set the integer to 1, they have brown hair, 2 for black hair, 3 for other. Then in our multiple selection if statement, we're saying if your hair color is 1, a brown haired person, it says to please stand. Let's have our brown haired people raise their hands. Else, if your hair color is 2, which would be our black haired people, turn your chair to the left. And else, if your hair color is 3, let's turn your chair to the right. So I should look out and I should see everybody either raising their hand or having their chair turned to the left or turned to the right. Awesome, everybody's got brown hair. Not everybody, good job. What I want you to notice is that when we're in instance, when we're executing this code, we're only going to be able to pick one of those. So there is no way that our code would run the stuff for brown hair and the stuff for other color hair. Only one alternative would work for each time we execute.
What if you have brown and gray hair?
You'd have to pick one. You have to pick one. I know, everybody's always like, oh, brown hair. And I look at them, I don't know, it looks pretty black to me.
No, gray.
Gray hair, yeah. No hair, I never know. Okay, so this is a flow chart for that, right? And in our flow chart, we have all these decision diamonds. So we have if hair color is 1, do this. But if it's not, check to see if it's 2. And if it is, do this. But if it's not, check to see if it's 3. And if it's 3, do this. But if it's not, finally do the final else clause. And then we could go do something that happens for all of them. That's multiple selection. And we actually see that happen a lot in the real world, right? Now, our biggest problem area in our textbook is the select case statement. Our textbook, our Prelude to Programming textbook, talks about the select case statement a lot. And it's a really important statement, but Python doesn't have it. So we can't do this code in Python, so it's something that we just have to remember is out there. And I'll remind you when we're getting to tests and things that are going to ask you about it, but it's just a weak area for us because Python doesn't let us do the select case statement. The select case statement is just like a multiple if statement, except that we can use a different syntax. We'll say select on hair color. In the case that hair color is 1, do this stuff. In the case hair color is 2, do this stuff. In the case hair color is 3, and if it wasn't any of those, do this. So the select case statement, if we look at the flow chart for it, you'll see it's a lot more efficient than doing all of those multiple if statements because we just look at hair color once. And then based on what the hair color setting is, our select case statement chooses the right code body to execute. So this is just one of those things that Python doesn't support. When you get to C# and Java, it'll be something that you'll be able to use. For now, it's just something that you have to file back in your memory banks and know it's out there and available. Now, sometimes just a simple if statement is not enough. Sometimes we need to make our condition compound and more complicated. For example, maybe I want to find people that have brown hair and are in row number 2. Or maybe I want to find people who have brown hair or black hair, either one. Or maybe I just want to find people that don't have brown hair, because we just had a very few of that. So I can use the logical operators and, or, and not to combine my conditions to make them more complex. Now, when I make my conditions more complex, notice I still have to have left operand, operator, right operand on each side. So I'm not simplifying the condition, I'm just joining them together. Those are logical operators. Whenever we're using the logical operators, things can get a little messy. We can use a truth table to make sure that we've tested all of the different alternatives. Sometimes we have to just test things over and over and over to make sure we've tested all the alternatives. This truth table, when I first look at it, doesn't really look like it has a lot of meaning, but it really does. So I have an X variable that's a Boolean. And I have a variable named Y that's also a Boolean. Based on the value of X and the value of Y, I can look at these different combinations. I can say if X or Y. Now, when would that condition be true? Well, it would be true when X is true and Y is true. It would be true when X is true and Y is false, because it's an or, and one of them is true. It would be true when X is false and Y is true, because again, one of them is true. The only way this or condition would be false is if X and Y are both false. Now, what about and? Here, I'm saying, what if my if statement says if X and Y? So in that case, if X is true and Y is true, the and condition is true. But if Y is false, my and condition is false now. X is false, my and condition is false. If they're both false, it's false. So notice how with the or condition, only if they're both false is it false. With the and condition, only if they're both true is it true. And then finally our not. Our not is just a big old mess, and it just takes everything and switches it backwards. So if I say not X and X is true, it will be false. If I say not X and X is false, it will be true. So it just switches everything backwards. Y is irrelevant there. I don't know why they have it because it says not X. But anyhow, that truth table kind of gives us an overview, all of the different ways that we would need to test our program. And it kind of is at a glance shows us how those things are going to be combined together to decide if they're true or false. Yay. Let's add an else statement. So we created our code here, our beautiful password program, and we've got our if statement, and we want to add an else clause. So when I press enter, I'm still indented because I'm still in that if statement body. So I'll just backspace to go to dedent, and then I'll type my else clause. And my else keyword is just going to say else with the colon because there is a body. Now in my else clause, I'd like to print a different message. Let's say access denied. And then we'll print another message. Sorry. Now let's run our application. And I'll try the correct password, secret. And it says, yay, you got it. Now I'm going to try it again. And this time I'm going to type in a bad one. And I should get my other message. Work. How's everybody? Doing okay? Everybody at home doing okay? Good, good, good. Everybody finished. All righty, we need to add our if statement then to our Python quick reference. So I'm going to add a blank line or so. And I'm going to start with my if statement. So if, let's see how we did it in the other class because it came out pretty good. Let's just do something easy like if x equals y. So I'm going to say if the condition is true, run the body. After that, we can add a little bit more. The body is all of the indented code after the colon. So when we're looking at our if statement, the if is the keyword. And then X and Y and all of the condition are the programmer defined names, but I'm not going to color code those because it seems like a little much, but you are welcome to, because that could be variables. We could be looking at strings. We could be doing anything in that test comparison. We could be running another function. In my if statement, in the if statement body, or in the if statement condition, I could say if input from this prompt, here is the input prompt, equal something, then I would go and continue on. Let's try it. I'm going to write a new program in Colab. I'm going to come down here and add more code. And I'm just going to put, try it with one line of code. We can't do it all with one line of code, but I could say print input, please enter the password. So I'll say try it with less code. How's that? So let me run that. We should be able to see that. First, it's going to prompt us for the password. Oops, in the wrong place. Print it. And then we'll print it. So I could say if input, please enter the password equals secret, print access granted. Bless you. Now let's try and run that. So I've got please enter the password. I want to type secret. We get the access granted message. So as we're looking at exploring things and we're putting things in our Python quick reference, you are welcome to just try some things, right? Because we haven't seen code that allowed us to embed statements within other statements. But if we prepare our minds for that, thinking we're going to see this as it comes, then we can be more prepared for it when it does hit us. Beautiful. There's our book. I have so many tabs open. Okay, here it is. I need to be able to rename them or something. So we left off with our wonderful secret. And in your Python book, as you read through it, they're going to explain all the if statement again, give you another chance to see it described in a little bit different of wording so that maybe it'll mean more, mean less. It'll be different. And then as you continue on, they're going to talk about the else clause. Now, on page 59, the very end, they branch off a little bit and they talk about the mood computer program. Back in the 70s, they had the mood rings. You guys have seen them. They have like mood pins and stuff now. They change color based on your temperature. Well, the mood computer takes technology to the next level by looking into the psyche of the user and displaying his or her mood. Sure it does. Okay, so it says figure 3.7 reveals my mood while writing this very chapter. How cute. Look at the cute little ASCII art happy face. Okay, so he says it doesn't really do that, but it's a good way for us to look at all these different if statements. So let's see if we can write this one. This will be our mood computer. I'm going to add a section and say this is mood computer. And I want to add some code under that. So this is our mood computer. Now, in our mood computer, we're going to need to generate a random number, so, and that's what we're going to use to determine the mood. So whatever we get for a random number will kind of decide our mood. So we need that import statement to import random. And then they'd like to have a welcome message. Our welcome message is going to be print, I sense your energy, your true emotions are coming across my screen. Kind of sneaky, huh? Ooh. Zoomed way in. I do like that with Pro Laboratory, it seems to be a lot easier for me to show you guys my code without it going wacky. Just won't let me press enter sometimes. There we go. All right, and now we want another print statement, and this one is going to kind of leave them hanging. You are ... and that's where we're going to leave it. We want to go ahead and generate a random number. Generate a random number for the mood. So we'll call that variable mood. We're going to get a random integer between 1 and 3. So as you see now that the co-laboratory AI is getting a little bit more intelligent, it's telling me about the randint function. Returns a random integer in range A, comma, B. And so it is giving me a lot more information as we go. Now, we've got our mood set. So let's determine the mood and display a message based on their mood. If our mood is 1, so in our last program, when we were comparing the password, when I said if mood equals secret, I had double quotes. Do I need double quotes around this 1? Is that a rule for if statements? Should I have quotes? Why?
Not a string.
Not a string. It's a number now. I don't put double quotes around numbers. These guys in the back are like, you're confusing. Sorry. But I have to say that because a lot of people have trouble with that because that very first if statement we did was comparing to a string. So I had double quotes. So it's normal for people to think, oh, I must need double quotes around this thing I'm comparing to get it to work if it won't work right. But no, we only use double quotes if it's a string, just like in other areas where we're looking at literals that we type. So since this is a number, we don't have quotes around it. We just say, is the mood equal to this number? If it is, let's print some things. This is our happy mood. So we'll have a comment there that says that. And then they want us to print, and they have one of those big giant ASCII art things. So let's just print happy mood. and I'll let you guys update it with the ASCII art. Now, if we are not happy, our mood is not 1, let's check to see if it's equal to 2. So there's my elif statement. My elif statement says, okay, the if statement wasn't true. How about this one? So when I'm using an elif, I have to have a condition just the same as with my regular if. So if you see that keyword if, you have to have the condition part. So if our mood is 2, in that one we're neutral, and EU, I guess. So I'll print neutral mood. Next, if they weren't happy and they weren't neutral, we know that our only other choice is 3. So let's put another elif. If our mood is equal to 3, then they were sad. We'll print sad mood. So now we've covered all 3 of the possibilities. When we generated our random number, we said we only want 3. We could put in a final else clause. The only way we're ever going to get here is if there's some sort of program error, right? Because we told the random number generator we only wanted 1, 2, or 3. So our elifs are going to catch it. But it's a good programming practice for us to go ahead and put in this final else and print out some sort of message. In their case, they're going to say illegal mood value. And then that'll be cute. You must be in a really bad mood. Then finally, no matter what mood they were in, we want to print out a message that says today at the very end. So I want that to be outside of my if statement structure. So I have to backspace or dedent. Then I can print ... today. As many typos as I've made, I do need to go ahead and buy a better keyboard, huh? I'll probably just make just as many. All right, let's look at our code here. We started out with our nice welcome message. Then we generated a random number to give us our mood value. Then based on our mood value, we're going to print out the appropriate message. Finally, at the very end, no matter what mood value we printed out, we're going to print out a final message to kind of wrap it all up. So let's run that. Here's our my true energies, blah, 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 blah. I am in a neutral mood today. I'll run it again. I should get a different value. A happy mood today. Now, this is a great one for us to run in that visualizer. Let's do it. I'm going to copy all this code. And I want to go to that website, that Python tutor website. Now on my Python tutor website, I can't just paste because I'm looking at this old code. I have to click edit this code to go back into their editor mode. Then I can delete the code I had and paste this new program. Using this visualizer is kind of like an online debugger, and a lot of programming languages have online debuggers available to us where we can step through the code line by line to see what's happening. So this is really, really valuable And it's something you might have to get used to. You might have to just keep trying it so it starts making sense to you. But I'm going to click Visualize Execution. And when I do that, again, the red arrow is poised right at the end of my black comment, ready to start running. So I'm going to click Next. We'll see our import occur. Next, our print statements for our welcome messages. Now we're going to generate our random number. We should see our mood variable pop up. And looking over here, as we visualize, we can already tell our mood variable has a value of 2. That was the random number it got. So as I look at my code, I should see it hit that if statement there for mood equal 2. If I start now, I'm looking to check to see if mood equals 1. I'm on that if statement. So if I click Next, I should see it jump past that first if statement. It didn't match. Now on this elif, it does match. So we should see when we click Next, the print statement get executed because it was true. We'll see the output, and then it'll jump down to the very end. Notice it doesn't keep looking at the if statement. It's done. It found the part of the if statement that it matched, so it jumps all the way to the end. Questions? Got it? I'm going to minimize this. Let's look at our Canvas stuff for our Module 6 for this week. The assignments that we have, you guys should be pretty well prepared to do. These are all due Monday night is how I set them up. I'm sorry I keep kind of fiddling with the due dates, so keep watching them. But with our different assignments, I'm trying to get things due like at the last possible moment, but before we come back to class again, so they're not hanging over still in your head. So these are all due next Monday night. The Chapter 4 review questions, the Python Code Academy Unit 3, and then this positive negative number program. You might find this one somewhere in one of your books that's very similar. So in this one, we want to know, we want to prompt the user for a number, and we're going to print out positive if it's a number that's greater than 0, negative if it's a number that's less than 0, and 0 if it's 0. So that's what that program will be. It doesn't need to have any functions or anything. It can just be if this, do this. Now, the Code Academy one I do need to mention. The first 2 modules of the Code Academy, I know you guys are doing the old 2.7 Python. Remember with the older 2.7, that free Code Academy stuff, you don't put parentheses with your print statements. That's the only difference, really, between that old version of Python and this new version. Code Academy, when they started, this Python course was their first course, this Python 2.7 course that you guys are doing. So when we started using it back a long time ago, we knew that there would come a time that Code Academy would probably start charging. I mean, you just could tell. We just didn't know they were going to be sneaky about it and make it be the updated versions of Python that you had to pay for. We always figured they would make the intro to Python stuff free no matter what. But they were like, no, this is our first course. It's our most popular course. If they want to take the new one, we're going to charge them. So that's why we're doing the older version, because it's still free. Now, when you get to Unit 3 of that course, and they start doing if statements, for some reason, they want you to really understand the information you're typing in the if statement. And there are some places where they make it into like really hieroglyphic typing practice, where you have to type all these weird special characters and it just keeps going and going and going. You guys all know how to type just fine. If you understand what the concept is, please copy and paste from the description window into the code window so that you don't have to retype all that stuff, or else you'll never get through this module or you'll want to kill me when you do. So you are welcome to copy and paste from the Code Academy description into the code window. Be sure you understand what you're copying and pasting before you do that, but you don't need to type it all. So when you get in there, you'll see what I mean, and you'll type a few of them, and then you'll go, ah, I bet this is what she meant. I don't have to type all of these because they are a little crazy. Questions about this stuff? How do you feel? If statements, if you've done programming before, are probably crystal clear. If you haven't, they might be a little muddy. That's okay. That's why we're going to keep working with them. So just try to get through this first program and not complicate it. On this one, start, look at your Python quick reference, think about what you need it to do, and just code it. Don't look for deeper meaning. You know, don't be one of those people that comes back and says, I just couldn't just print negative because I thought there was a deeper meaning. There isn't. If the number is negative, just print negative, that's all. We don't. So sometimes people can really make themselves have a hard time by complicating stuff, and we don't need to. Questions? All right, you guys have got it. Next time, we'll look at starting while loops and keep going in our book. So for home, this Python beginning programming book can be put away. You need your prelude to programming book to do the short answers and stuff. Yeah, if you have any questions, I'll be around. Thank you, you guys. I feel like our class just keeps getting smaller, but I think it's bigger than a lot of them. It's just a bunch of them at home. So that'll work out. Since everybody's doing so good. But yell if I'm wrong when you're not doing good. Have a great week. Have a great weekend.
Mrs. Riley?
Uh-huh.
I have a question.
Sure. Hard to see mouths move.
Yeah. It's not about today's class, it's about this computer. Every time I come in here, it seems like whoever was just on it is already signed in, and this is still there. It says he's still signed in, and it's been like that a couple times.
Log into his Facebook.
No, I know who it is. Yeah.
Okay, so
Yeah,
he's
you're
not
okay.
signing out because I clicked.
It's the
sign
person
in
that
to
has
get
a
the email.
laptop, and so we shut the laptop and this one, and I think he's forgetting about this one. I'll remind him. Because I don't think it hurts anything. I think someone's staying logged in on this one up here all the time, too, because it always just asks me if I want to log in as another user. You know, and it doesn't usually bother me, but kind of spooky.
A little bit, yeah.
Yeah.
Figured I'd ask. Just to
Is
double
it just
check.
like the front screen or like Google or something?
No, they're still logged in, so I mean, they theoretically they could have something running that was doing something. I'm a paranoid person like that. Quick key login, my stuff.
How's it going?
See you guys.
All right.
Yeah.